Earthquakes are natural events that shake the ground. They happen when energy stored in the Earth's crust is suddenly released. This release of energy causes seismic waves which travel through the ground. These waves are what make the ground shake during an earthquake. The Earth's crust is like a jigsaw puzzle made of huge pieces. These pieces are called tectonic plates. The plates constantly move, but we don't usually feel it. However, sometimes the edges of these plates get stuck. When they finally break free, an earthquake happens. The release of energy can be powerful. It can cause buildings to collapse and roads to crack. The shaking can be felt over large distances. This is why earthquakes are considered one of nature's most dangerous events. Understanding why earthquakes happen helps us prepare better. Knowing the underlying causes can also help in designing safer buildings and infrastructure. The Earth's crust is divided into several tectonic plates. These plates are massive slabs of solid rock, both continental and oceanic, that fit together like a jigsaw puzzle covering the surface of our planet. These plates float on the semi-fluid layer of the mantle beneath them. The mantle is composed of hot, molten rock that behaves like a thick, viscous liquid over geological timescales. The plates move because of the heat from the Earth's core. This heat creates convection currents in the mantle which act like conveyor belts, slowly shifting the plates above. This movement occurs very slowly, about as fast as your fingernails grow. Despite this slow pace, the movement of tectonic plates has a profound impact on the Earth's surface over millions of years. There are three types of plate boundaries: divergent, convergent, and transform. Each type of boundary results in different geological features and activities. At divergent boundaries, plates move away from each other. This often occurs along mid-ocean ridges where new oceanic crust is formed as magma rises from below the Earth's surface. At convergent boundaries, plates move toward each other, often causing one plate to move beneath the other. This process, known as subduction, can lead to the formation of mountain ranges, deep ocean trenches, and volcanic activity. At transform boundaries, plates slide past each other horizontally. The friction between the plates can cause earthquakes along faults, such as the famous San Andreas Fault in California. The movement of tectonic plates is not smooth. The edges of the plates are rough and jagged, causing them to catch and stick as they move. Friction causes them to stick at their edges. Over time, stress builds up as the plates continue to push against each other. When the stress on the edge overcomes the friction, there is an earthquake. The sudden release of energy sends shock waves through the Earth. This is why most earthquakes occur near plate boundaries. The constant movement and interaction of the plates create zones of high stress and seismic activity. The interaction of these plates can build up a lot of pressure. This pressure can deform rocks and create faults, which are fractures in the Earth's crust where movement has occurred. When the pressure is released, it sends seismic waves through the Earth. These waves travel through the Earth's crust, causing the ground to shake. This is what we feel as an earthquake. The intensity of the shaking depends on the amount of energy released and the distance from the epicenter. Understanding plate tectonics is crucial. It helps scientists predict geological events and understand the processes that shape our planet. It explains why certain areas of the world are more prone to earthquakes. Regions near plate boundaries experience more frequent and intense seismic activity. For example, the Pacific Ring of Fire is an area with many earthquakes and volcanoes because it is a boundary of several tectonic plates. This region is a hotspot for seismic and volcanic activity, making it one of the most geologically active areas on Earth. Faults are cracks in the Earth's crust, which are essentially fractures or zones of weakness. These cracks occur where blocks of rock have moved past each other, often over long periods of geological time. They are formed by the immense stresses that build up when tectonic plates, the massive slabs of Earth's lithosphere, move and interact. There are three main types of faults: normal, reverse, and strike-slip, each with distinct characteristics and formation processes. Normal faults occur when the crust is being pulled apart, a process known as extensional stress. In a normal fault, one block of rock drops down relative to the other, creating a visible displacement. Reverse faults, on the other hand, happen when the crust is being compressed, a result of compressional stress. In this scenario, one block of rock is pushed up over the other, leading to an uplifted landscape. Strike-slip faults occur when rocks slide past each other horizontally, driven by shear stress. Most earthquakes happen along these faults, as the built-up stress is released suddenly. The movement along a fault can be sudden and violent, causing significant ground shaking and damage. This movement releases energy in the form of seismic waves which travel through the Earth and cause the shaking felt during an earthquake. The point inside the Earth where the fault movement starts is called the focus or hypocenter. The point directly above it on the surface is called the epicenter, which is often the location of the most intense shaking. Faults can be found all over the world, from the ocean floors to mountain ranges and even beneath cities. Some faults are very active, moving frequently and causing regular earthquakes, while others move very slowly, accumulating stress over centuries. Understanding faults helps scientists determine where earthquakes are likely to happen, allowing for better preparedness and risk mitigation. This knowledge is used to create detailed earthquake hazard maps and improve building codes, ensuring structures are designed to withstand seismic activity. Section 4. Seismic waves, the Earth's shaking messenger. Seismic waves are the waves of energy caused by the sudden breaking of rock within the Earth. They are the waves we feel during an earthquake. There are two main types of seismic waves: body waves and surface waves. Body waves travel through the Earth's interior. They are divided into two types: P waves and S waves. P waves, or primary waves, are the fastest and first to be detected. They can move through both solid and liquid layers of the Earth. S waves, or secondary waves, are slower and can only move through solids. Surface waves travel along the Earth's surface. They are slower than body waves but can be more destructive. There are two types of surface waves: love waves and Rayleigh waves. Love waves cause horizontal shaking, while Rayleigh waves cause a rolling motion. Seismologists use seismographs to detect and record seismic waves. By studying these waves, they can learn about the earthquake's location, depth, and magnitude. This information is crucial for understanding and mitigating the impacts of earthquakes. Section 5. The Richter scale measuring earthquakes. Earthquakes are natural phenomena that have fascinated and terrified humans for centuries. Understanding their magnitude is crucial for preparedness and response. The Richter scale is a numerical scale used to measure the magnitude of earthquakes. It provides a standardized way to compare the size of different earthquakes, regardless of where they occur. It was developed in 1935 by Charles F. Richter, a seismologist at the California Institute of Technology. His work revolutionized the field of seismology. The scale is logarithmic, meaning each whole number increase represents a 10-fold increase in measured amplitude and roughly 31.6 times more energy released. This logarithmic nature allows the scale to accommodate the vast range of earthquake sizes. An earthquake measuring 4.0 on the Richter scale is considered minor. Such earthquakes are common and often go unnoticed by people. It might be felt but usually causes little damage. These minor tremors can serve as a reminder of the Earth's dynamic nature. An earthquake measuring 5.0 to 5.9 is moderate and can cause damage to buildings. These earthquakes are more noticeable and can lead to structural issues. Earthquakes measuring 6.0 to 6.9 are strong and can cause severe damage in populated areas. The impact of such earthquakes can be devastating, especially in densely populated regions. Major earthquakes measure between 7.0 and 7.9. These powerful events can lead to widespread destruction and significant loss of life. These can cause widespread and serious damage. The aftermath often requires extensive rescue and recovery efforts. Great earthquakes measure 8.0 or higher. These are the most powerful and destructive earthquakes known to humanity. They can cause devastating destruction over large areas. The impact of such earthquakes can be felt globally, affecting economies and societies. Seismographs are used to measure the seismic waves produced by earthquakes. These instruments are crucial for detecting and analyzing earthquake activity. The data collected is then used to calculate the earthquake's magnitude. This information is vital for understanding the earthquake's potential impact and for issuing warnings. The Richter scale helps scientists and emergency responders understand the severity of an earthquake and respond appropriately. By providing a clear measure of an earthquake's strength, the Richter scale plays a key role in disaster preparedness and response efforts. Public education and community drills are essential in preparing for earthquakes. Understanding the Richter scale and its implications can help communities better prepare for and respond to these natural disasters. Section 6. Practical tips for earthquake safety. Knowing what to do during an earthquake can save lives. Here are some practical tips to help you stay safe. First, drop, cover, and hold on. Drop to the ground, take cover under a sturdy piece of furniture, and hold on until the shaking stops. If you are indoors, stay away from windows and exterior walls. Do not use elevators. If you are outdoors, move to an open area away from buildings, trees, and power lines. If you are driving, pull over to a safe location and stay inside the vehicle. After the shaking stops, check for injuries and provide first aid if needed. Be aware of potential hazards such as broken glass, damaged buildings, and downed power lines. Listen to emergency information and follow instructions from local authorities. Being prepared can make a big difference. Have an emergency plan and a supply kit with essentials like water, food, and medications. Practice earthquake drills with your family so everyone knows what to do when an earthquake strikes. Section 7. Conclusion. Summarizing the main points. Earthquakes are powerful natural events caused by the sudden release of energy in the Earth's crust. Tectonic plates and faults play a key role in causing earthquakes. Seismic waves are the energy waves that travel through the Earth and cause the ground to shake. The magnitude of earthquakes is measured using the Richter scale. This scale helps us understand the severity of an earthquake. Knowing how to stay safe during an earthquake is crucial. Remember to drop, cover, and hold on, and be prepared with an emergency plan and supplies. Understanding earthquakes helps us build safer communities. While we cannot predict earthquakes, we can prepare for them. By learning about the causes and impacts of earthquakes, we can reduce their risks and protect ourselves and our loved ones.